Okay, it says the red pyramid is an Egyptian pyramid with a square base length of 220 meters. The slope is approximately 43 degrees. Approximate the length of an edge of the pyramid to the nearest tenth. Okay, people, this one is going to be a little bit intense. Initially, I thought it was going to be pretty straightforward because I thought, oh, well, it's just the slope of one of the sides of the pyramid as 43 degrees, so I can just, basically draw the face of the pyramid and calculate the 43 degree angle, but that is not the case. It's more complicated than that. So what I'm going to start with is the base of my pyramid. And I don't know if you remember this from geometry, but when you're drawing a pyramid with a square base, what you need is a rhombus, okay? We know we need a square base because it says that it has a square base, okay? So then go to the center. So what you see right here is the floor of the pyramid, right? So there's the center. Now I'm going to draw, this is the height of the pyramid. And then what we have here are going to be basically the edges to create the three-dimensional shape. So all I'm doing here is just taking from each of these corners of the pyramid floor, I'm just drawing it up to the peak, all right? So now what I want you to see is that each of these lengths is 220, okay? So this is 220, this is 220, obviously the back and the sides are also 220 because it's a square pyramid. So what we need, what we know is that what we're supposed to, we're trying to figure this length out, people, okay? The problem is we need to know, essentially, there is a right triangle that's sitting right here, okay? And so we need this dimension right here because we know that this angle measure is 43 degrees, okay? This angle measure right here is 43 degrees. So if we would know this, we could figure out we can figure the rest of it out using trig functions. So I'm going to recommend that we finish it out by getting the diagonal of the square floor of the pyramid. We know, because it's square, we know that it's a 45, 45, 90 triangle. So essentially what we have here is if you've got a 45, 45, 90 triangle, this is 45, this is 45, that means you have 1, 1, and square root of 2 here. So we can draw, this is our reference triangle, and then we can draw the base of the pyramid, from the pyramid floor. So I'll just draw that here. So we know this is 220, we know this is 220, and we're trying to figure out what this is, okay? That would give us this X value right here, would give us the green diagonal on our pyramid floor. So let's set this up. Let's say 1 is to the square root of 2. 1 is to the square root of 2 as 220 is to x. Well, now I hope you can see by cross multiplication that x is equal to 220 times the square root of 2. All right? So if that is the green diagonal length, x equals 220 times the square root of 2, that means that this red length right here is equal to 110 times the square root of 2. Do you see that? Because it's half of the whole green diagonal line. Now, we want to know what this length right here is. So we can set up a trig function to go with to figure that out. We know that the adjacent, this is the adjacent side, and this is the hypotenuse. So that means we want to use the cosine function, I believe. So if we say the cosine of 43 degrees, cosine of 43 is equal to the adjacent, which is 110 times the square root of 2 over this, which is our hypotenuse, okay? So now, the rest is just a matter of calculating it. That's actually probably the easiest part. So if you take cross multiply, you get h times the cosine of 43 degrees is equal to 110 times the square root of 2. Divide both sides by the cosine of 43 degrees. Cosine of 43 degrees. Now all you have to do is enter this into your calculator. You should, as your height, you should get approximately 212.7 meters. I said as your height, I meant as your hypotenuse. So approximate the length of an edge of the pyramid to the nearest tenth. That was one of these edges. I think the critical thing to recognize with this one is that you needed to know that there's actually a right triangle. Whoops, that was kind of messy there. A right triangle sitting right here. This right here formed the right triangle. And that's a little harder to see, especially if you don't have a three-dimensional object.